Alright, so we've got the most missed problems from our second convergence set of multiple choice. So number 12 was one of the ones that was missed quite a bit. So this is, what is the value? So it's asking you for an infinite sum. Alright, so first thing I'm going to do is I'm going to restructure the inside a little bit so it looks more like the structure that we need to see. So initially, I'm going to think of that as 2 times 2 to the n in the top, and in the bottom 3 to the n. Now if I restructure one more time, I have a 2 out front and a 2/3 raised to the n inside. Now, hopefully that raises the red flags that this is a geometric. And in a geometric, we know that it's the first term over 1 minus r gives us the infinite sum. All right, so in this one, our first term, we're starting at n equals 1. So I plug a 1 in there, I get 2/3 times 2, which is going to be 4/3. That's the top. All right, and then 1 minus r here is 2/3. So I have 4/3 over 1/3. All right, and multiply by the reciprocal, so that's going to equal 4. All right, so the correct answer here is C. All right, correct answer is C. Probably the most common mistake that people make on this one is they throw a 2 in the top, and they get D as the answer, because again, they're using the 0 term instead of the first term. But we always use the first term of the series that we're adding up when it's geometric, not like a specific format or structure. We always plug in the first n value that we're using, and we go from there. All right, on 13 was the next most missed problem. This says, what are all values of p for which the infinite series n over n to the p greater than or plus 1 converges? All right, so we know our borderline for p series is 1 over n. And from the things we've done in class, we also know if we add numbers to the bottom, even though that makes it just a little bit smaller, it still really behaves just like 1 over n, so we end up with something that diverges. So we need that n to the p to be something bigger than n to the second, because that gives you the ratio top to bottom of a n to an n squared, or n to an n cubed, or n to n fourth. All right, if we go right at 2, right, that would give us really an n over n squared plus 1. And that's not enough to make it break away from the structure that we know is divergent, which is the one for 1 over n to the first. All right, so if I go from here, what I'm going to need to do is I'm going to need this exponent, when it's reduced with that 1 in the top, to be just above 1. All right, and the only way I can do that is if the p-value is greater than 2. All right, it can't be equal to 2, because if it equals 2, then I'm at n over n squared plus 1. All right, and then we could do, a limit comparison test would probably be the easiest. So we could compare to 1 over n, which is divergent. All right, and we're going to get that these both diverge. But as soon as I creep that 2 a little bit higher, even if it's 2.001, it's going to be just enough to push it past this threshold into a convergent series. All right, so the correct answer on that one is E, p greater than 2.